The topic is describing a distribution and choosing summary statistics. Alright, let's do this example. A university teacher saved every email received from student. He then counted for each student who had sent him at least one email, how many emails each student has sent. So the distribution is a number of emails received from each student by the professor. So that's what he counts. So for example, 80 students send the professor between 1 and 2 emails, and so on. So he received 80 emails. 80 students send him between either one email or 2 emails, and so on. 40 students send him send him only 1 email. Remember, 2 we don't count, it's in the next. So 80 students send him 1 emails, 40 students send him 2 emails, and so on. 1 student send him 21 emails right there. That's 1. And it's hard to write a 1 there in the small unit. Alright, so let's do this example. From the histogram, would you expect the mean or the median to be larger? Just remember this by definition. It's easy to prove when it's skewed to the right, when the distribution is skewed to the right, automatically the mean will be bigger than the median. For example, here the median is right there, but the mean, because of this 21 that you have to add, the mean will be somewhere in here because of those 21 emails. Because you need, when you do median, you add all of them and divide. So you're gonna add 21. You add 21 to the sum. Remember, the mean is equal to the sum of all those emails received divided by n, the number of counts. Alright, so by definition, when it's skewed to the right, the mean is bigger. When it's skewed to the left, the mean is smaller. Well, actually, when it's symmetric, they're really close. The median and the mean are close to each other. But of course, a better approximation for symmetric will always be the mean. Right, so from the histogram, would you expect the mean or the median to be larger? So definitely I'm going to say the mean is larger than the median. Why? Because distribution is skewed to the right. So remember, if it was skewed to the left, that would be the other way around. Again, describe the distribution. So the shape, so the distribution of, I always start with the variable, the distribution of number of emails received from each student by the professor is skewed to the right We need to talk about the modality, unimodal, bimodal. Definitely is unimodal. As included in the shape. The center will be, most of people, the mode is one email, most of people send, but that would be around 2 emails. The median is about 2 emails. It's between 1 and 2. It's really close. What else? The spread, how many students he received from students. He received between, that's the range, between 1 and 21 emails from each student. Means there's one email, and there's an outlier. Well, before we talk about the outlier, was so that's the spread. And then unusual features is there's an outlier of 21 emails. So one student sent 21 emails. That's it. Then, which summary statistics would you choose to summarize the center and spread in this data? Remember, there's only 2 cases that we know so far. If it's skewed, it doesn't matter whether it's right or left. You use median and IQR, the inner quartile range. This is for the center, right? And this is to describe the spread. If it's symmetric, then we use mean for the center and standard deviation to describe the spread. So what do you think? Since it's skewed, then the answer will be we use median to describe center and the IQR, the inner quartile range, to describe the spread. And that's it for this example.